Hi everyone. Today we're going to go over this ventilator. It's a Bear One ventilator. It's about 30 years old. It's very simple designs. It's actually work as new, okay, because it's have been going through preventive maintenance by our departments for many times. All right. And then we're going to go over the structure, the component of the breathing circuit that fit this particular ventilators. After that, we're going to look at how to use this ventilator analyzer, okay, how to hook up this ventilator analyzer to check the performance of these ventilators. Okay, stick around. On the back of the machine here, it's got two gas inlet over here. One is the oxygen, one is air, okay? And it's got pressure regulators. Actually, this is it's a small regulator inside of the check valve, and also this is the pressure gauge. Is the pressure gauge is detecting how much pressure is coming in from the hospital pipeline, right? And also this one have the hourly meters, how many hours have been used. Also they have, this is like a foam, the filter, and they have the main switch over here. This is just a main circuit breaker. This is just they have protection just to prevent somebody turn it off, okay? And then I have opened the back panel here, just to show you they have power supply. They have the battery backup for the alarm system, and it have circuit, many of the circuit down there. Let me show you what is in there. This is a power of the power supply system, and they have a circuit, different circuit that control the alarms, have a microprocessors control, also that supply the voltage to different component inside of the machines. I don't know, you can see that over here inside they have a pneumatic system. They have pressure regulators. Down here they have a pressure switch. Also, they have some small pumps in here. Is for the nebulizer, and also underneath here, down below. It's down below is below of the machine is actually. Let me take that to show you. Underneath the machines. Down below, you're going to see that we have here is an internal air compressor. Okay, so in case we lose the oxygen or air or hospital, or we can run just only air compressor. Okay, it's have a built-in air compressor down here. Okay, and also I have a whole bunch of pneumatic system. It's got pressure regulators, got demand valve system. Also over here, this is the pumps that actually this pump is function as the driving force for nebulizer. And also have a built-in up here, and we can see that that's inside here. We have an oxygen blender built into this machine here. Inside here, you probably can see that it's got the switch, to detect that oxygen or airs. Okay, just in case you don't see that, I pointed there. Okay, that's a pressure switch. In case we lose anything, that is going to cause the alarms. Okay. Also, this inside here, inside this block here, you have a check valve to make sure air coming in and the air from the hospital pipeline cannot really, actually it's all one-way valves, okay? So allows to, air will not escape. So just in case if we lose the air pressure, if we run them from the compressor, so the compressor won't lose the air to the cell or escape, air will escape to the hospital pipeline system. Okay, so from this side, probably can see air compressor, and also that this power supply, okay, of the unit. Okay, so let's turn this machine around. Okay, so this machine here, what is have here on the top part here, the top part is have, on this side is the indicators of the functions of ventilators. On this one, on this side is indicates all the alarms. Okay, so what it does is have the exhale volume display and the rate, okay, IE ratio, and this have status, okay, of the machines, and the mode is the function, the mode control, okay, which mode that we are selected, okay, and then we have proximal airway pressure right here, okay, and then this have the inspiratory source. So basically, anytime when we have the gas delivered to the patients, it will indicate is that a control, or it does that spontaneous, or it does assist mode, or is that is a sign of that patient, or like a deep breath. Okay, all right. So when we come over here on this side, anytime when alarm occur, this LED will lit. Okay, it will tell us and say, well, what actually happening at that time. So this LED will not go away until the problem is being corrected. All right, so it has been corrected. So this LED here is very important. Anytime we get an alarm, we always come to look and say, what's going on? What really happened with the patient here? That's what it's telling us. Okay, so now it comes down to this control panels here, okay? The control panels, there are so many of setting, all right? We have that on-off switch, all right? On-off switch right here. And also we have the control mode that we supposed to be selected what we going to give a gas to the patient. Are we fully controlled for the patient? The patient totally sedated. All right. So that's what we're gonna have to select here. This most of the time the doctor will order this. Okay. And then we have this. This is a single breath. I mean the manual. The manual trigger here. When anytime we want to give the patient a breath. So that's what we press is over here. All right. And then we'll come over at this, the tidal volume. This is something that we set, okay, based on the height and weight of the patient. All right, approximately the size of the lungs of the patient. So we set this at the tidal volumes. It is how many liters, how many milliliters, of tidal volume that you want to give to the patients. And then we have the normal rate. So this is the breathing rate, okay, or respiration rate, okay. And then we can actually, multiply this. So we can the scale of this from 5 to 60, and then if you want to divide that by the 10, doesn't mean you can get 0.5 actually is half a breath to 6 breaths per minute. All right, so that's just pretty unusual, right? To go that low. All right, so that is the respiration rate setting. Okay, and then we'll come over here. Okay, come over here. is the normal pressure limit. So this is something that we have to really make sure that we not over pressure the patient's lung. So we have to keep this limit. Okay, it's going to limit that pressure. So we always have to watch that. So we won't, blow up the patient's lungs. So we have to kind of keep this limit, for the patient's lungs. So the air, actually the air that we deliver to the patients. Okay, and then after we have the height overpressure limit, we have the alarm. Actually, this one is part of the alarm. This column here, if you see this column here, this is the alarm setting. Okay, this is alarm settings on this column here. All right, so we can set the low inspiratory alarm. So when we have the upper alarm limit, we want to make sure that the pressure that we give to the patient is not, drop below certain points. All right, below certain points. So, let's say if the patient have, breathing at around 20 centimeter of waters, based on this proximal airway pressure here, when we run the machine. So we want to set this probably around 15, something like that, okay, 5 below. So, it's allowed that, if the patients, can still, lose a little bit pressure, but cannot drop below that. Or if that breathing circuit somehow get disconnect, this one will give us alarms, because when this, the breathing circuit is disconnect, we're not going to have a pressure. Right, so that pressure is gonna drop. Right, it will never reach as 20 centimeter of water. All right, so we'll come over here. Okay, sometimes we want to do work on something on the patient. We can push this button to go to a standby unit. So the machine will stop doing anything. It just go to the standby. All right, it won't do anything. All right, and then we have the sign here. Okay, sign. This is for like a deep breath, so we can actually set this one. This is additional from normal respiration rate. So if you set like a 10, and then we can have you put sign at 1, and 1 here, and then you can actually set, say sign to always have the volumes more than normal tidal volume. It has to be more than normal tidal volume, okay? And then, so we can set here, this is at 1. Okay, 1 is, what does that mean, 1 in here? As the mean is, you have, this is multiple, 60 in over here. What's the mean here? If it says like 60 multiplied by 1, that means 60 deep breaths, right? Deep breath. 60 times in 1 hour. Was a minute. Every minute you will have 1 deep breath, okay, on this one. And then we can actually setting alarm for a deep breath. Let's say, if you have that, this is not the alarm. It is a pressure limit. We don't want to have like a deep breath of the pressure go too high. All right, so we have to limit that. So we used it to limit that. Okay, but the thing is, this one will actually will give you some sort of alarm, because when you have a limit, if the sign pressure is hit the limit, it's going to alarm. Yeah, somehow is going to alarms. Okay, as the pressure limit. Okay, as the pressure limit. Okay, it's the same thing on the normal pressure limit. Is anything that set off the alarms is going to go to the pressure limit LED indicator here. Okay, is the pressure limit is going to alarm to tell you that, hey, there's something going on with the pressure limit that you're setting. All right. Okay, and then we come over here. That's actually we have a minute volume. Accumulated. This is have something to do with exhale volume. Anytime when we press this, that is the minute volume over there, it will show as this the minute volume, okay, instead of like entitled volume, okay. So that will be minute volume when we press this button over here. Okay, if we push the button, it activates the minute volume calculation. Okay, and then we will come over here. And when we come over here, this is kind of like a waveform that we want, the machine to really send the gas to the lungs. That you want to go smooth up, and then exhale, kind of slow it down, or you want to go up, quickly, and then pause, and then drop down as a straight line, as a square wave, something like this. You can select that. Okay, it depends on the the type of the patient that we want. Okay, and then we'll come here. We'll call this assist sensitivities knob. So we can select this for that assist control modes when we how sensitive that machine can detect the negative pressure when the patients try to breathe on their own. Okay, when they try to breathe on their own, is if we set sensitive more, what does it mean is the patient try to breathe, he or she doesn't have to create much negative pressure, just try to breathe in a little bit, the machine will detect that, and then it will actually, help the deliver gas to, his lung right away. But, sometimes we want to wean off the patient, we want to get the patient exercising more, so we set this to the less. Less mean is the patient have to really pull a lot of negative pressure to be able to activate the assist mode from the machine. So the machine will actually looking at a higher negative pressures, right, for the patient to be able to activate that assist modes before the machine can actually help pushing the gas, to his lung. Okay. So now when we come over here is the IE ratio. So this is IE ratio limit here. We can turn on and off here, the ratio limit here. That's what this activate this, I 1-to-1 ratio limit. And then anytime we'll activate the turn on and off, it will affect the IE ratio, the display on the top over here. Okay. And then we have come down here, minimum exhale volumes. We talk about this minimum exhale volumes alarms. This one here is keep detecting. What is minimum here? Anytime that when is the machine is deliver gas to the patients, and then if is detecting that the patient did not get the right amounts, okay, the right amounts, it will alarm. So this is kind of another alarm, this safeguard that we monitor the volume. Okay, we monitor the volume that we send. It's supposed to be tidal volume. If we set, tidal volume here, right, 1. And then you come over here, and then the patient is supposed to be exhale as around 1, and then we're looking at it and say, okay, minimum, right? That's mean 1 or 8, okay. And if what happened if we set tidal volume at 1 and we set this more than 1, this is going to alarm because exhale volume. Never, okay, it have to be equal or a little bit less than tidal volume, okay. So normally we're gonna kind of, make sure that it's around a little bit less than tidal volume when we set this, or we can set this to the off position, okay. And then when we come over, down below here is alarm silence. Alarm silence. Sometimes when we have that, the machine go crazy with all the alarms, and we see this, and what do we are, instead of let the alarms runnings and or alarmings drive everybody crazy. So we push this to kind of silence that audible alarms, and then we'll kind of try to figure it out, what really the problems, and then we can solve that problems, and then that alarm will go away. Okay, and then we'll come over here on the left hand side here. So we see this one. It says, this is oxygen blender, so or FiO2, or fractional inspiration oxygens. So this one we set as normally we'd run from the air compressor. We would like to keep this one at 21. If we don't have oxygen, if you don't have oxygen, and we set this above 21%, that low oxygen pressure alarm is going to alarm. All right. So we will see like low oxygen pressure alarm somewhere around here. We'll see that low pressure is gonna turn on. All right. So we keep this one at 21%. Okay. Now we'll go back to this control here. We have a peak flow. The peak flow is the amount of flow that we want to give to the patients, in 1 minute. So how many liters? It said, is sending to the lung is pretty fast. It doesn't mean that the patient gonna get the whole thing, the 20 liter, in one shot. Okay, no. But this one, it have to be divided by the respiration rate also. Okay. So that will continue, giving to the patient. This peak flow will affect that the waveforms of the gas that pushing the gas to the lungs of the patients. Okay, and then the next one here we call the inspiratory pause. The inspiratory pause here is the time that when you exhale and then you hold the breath. It's like when you breathe in and then you hold your chest, your breath for a few seconds, and then you exhale. All right. So this is kind of like we setting it like, okay, we want the patient to the machine to push the air into the lung of the patient and then hold it for 1 second before it's exhale. All right, or 2 seconds, and then exhale. Okay, so this is is a inspiratory pause. Okay, so you inhale, hold it for 1 second, 2 seconds, and then exhale. Okay, so that's inspiratory pause. Okay, so the next one. Okay, so the next one we call that nebulizer switch. Okay, nebulizer function here to deliver inhalation medication. So this is the amount of air from that nebulizer that pushing the medication mist mixed with the air that will deliver to the patient. Actually, it kind of subtract that from the total of the tidal volume for one amount. Yeah, let's see if the tidal volume is about 500. The nebulizer will be around 150 milliliters. Okay, for the nebulizer. So, and then we'll mix with that medication, and then mix it back into that 350. The total of the tidal volume is still 500. So we use this for that medication therapy only. Okay, and then we'll come to the next one here. Is we call the PEEP. Okay, and the PEEP here is actually stand for positive end expiratory pressure. What it does is we want to make sure that the patient, when they exhale, the lung is still not completely collapsed. So we keep the lungs, pressures, up a little bit. Normally it will probably be 5 centimeters of water and things like that. So the alveoli will not collapse completely. So when the next breath comes, so the air will move into the lung is quicker. And then during that PEEP activate the alveoli and have ability to push the oxygen out from that alveoli to that oxygen cells, and capillaries, more. Okay, and then we come over here, PEEP CPAP. Basically, if we run PEEP or CPAP here, we want to make sure. Okay, a PEEP CPAP knob here. This is for when we set PEEP. This is to allow the patients, to breathe on their own. All right, and then CPAP. What does that mean? Is if the patient, we want to make sure that we detecting positive pressure from the patient when the patient breathe in, breathe out. So if the patient is not breathe, okay, is going to alarms, okay? It will alarm. So this is caused that the apnea to alarm. So it's helping, detecting the apnea alarm also for the PEEP CPAP. All right. Any that pressure drop below a certain set point, all right, that means the patients have to breathe on their own, and continue push the pressure more than the setting, okay, and then that will satisfy this setting, okay, as a PEEP CPAP. All right. Okay, now we're going to talk about a breathing circuit. Okay, this part of the breathing circuit here. The breathing circuit is got two sides. One is actually inspiratory side of the breathing circuit, and then it's going to go to the patients. They have the Y here, and then they have filter. All right, the filter, and then this is going to go to, this is a test lung. All right, I use this as a patient, and okay, this is a test lung for the patients. And then when the patient exhale, it's going to come back to here, past this valve here we call, number 4. This, let's see, you can see that. Is expiratory valve. All right. So this is what function is this? Is will close during the patient's inhale, and then when the patient exhale, this is open. So allow the gas from the patients to exhale. To this is water trap. All right. So basically, it's trapped the moisture, and then it's going to flow to this flow sensor. This flow sensor here is detecting the flow and tidal volume, okay? And then we have this filter, so to make sure that it filter out bacteria and all the things like that when the patient exhale, it's going to stay over here, all right? So when we look at this, okay, from the front of this machine, there's another connector here. This is the nebulizer. Okay, we can have another tubes, connect to nebulizer containers, so they will dry the gas from the pumps, right? And then we have the exhalation valve. This tubing here, this tubing is actually connect to the back of the exhalation valve. It's got a mechanism, a driving mechanism back there to actually, activate this exhalation valve to turn on and off exhalation valve during the inspiration or expiration. All right, and also at the front here we have the proximal pressure monitor. Basically, in the back here, it's got tubing connect back all the way to the back over here at this proximal airway pressure. This is the analog gauges. All right, it have a range from -10 to plus 100. All right, -10 to plus 100 is number 5 over here. It's called proximal airway pressure. Okay. Now, this tubing here actually is connect all the way. You see, this is all the way to actually what is number here is number 2. All right, is number 2. Is connect at the Y. Okay, this is close to the patients. So basically, it's monitor that proximal airway pressures, is the real time, right? This is the real time. So it's easy to connect that. So we have most of this tubing and connector is have different sizes, okay? And then we have down here we call that connector for the flow sensor, okay? It can is a wire, like a bungee cord here is go to number 3, which is that's the flow sensor, okay? And then we'll come over here. We look at here. So this is a humidifier, okay? So today we're just gonna bypass the humidifier, okay? All right. So the humidifier here is number 7. It's humidifier, all right? And then what we look at is how we connect this. Okay, we have that. Number 8 here, we call that, normally we have another bacterial filter. It's connected to the patient circuit. So this is the, inspiratory, port, okay, or gas support. Number 8 here, you have the tubing go all the way to the Y connector. So see here, have it marked as number 1, right? This is number 1 as a Y connector, right? Going over here, I'm looking at here is, I think it's at number 9. We call this one is exhalation, okay? It's the exhalations, exhalations limb or exhalation tubing, okay? From exhalation tubing here, we're looking at this, number 4 is exhalation valve, okay, exhalation valve, and then after the exhalation valve, there's a tubing over here. We see this one, or number 6, is we call the exhalations, tubing. All right, so this is exhalation valve tubing. And number 6 here, what I see is this come down here. We see, we have number 3 mark here is we call the exhalation flow sensor, okay. And then I see the number 10 here. What we call here is water trap. All right, number 10 is a water trap. Okay, so when the patients, exhale, it's a lot of moisture. Actually moisture from humidifier also get to the lungs, and then the patient just try to, exhale. That sometimes, and not sometimes, most of the time, just they will actually put out a lot of moisture also. So that is. The water is a collector, okay, from the exhalation gas. Okay, and then we come over here at the front again. We'll see here we have nebulizer, all right, nebulizer connector here. That we have a special connector for it to go to that special container that can connect at this part here. Normally they will put the nebulizer around here, okay, to do the medication treatment, all right, to give it to the patient. That's that nebulizer gonna be connected to here, okay. And then we have a port here. So this port here can be 2 purposes. It can be for the temperature probe, or can be for for the medication, for inhalation medication, so they can inject that inhalation medication in here, all right, in this port, okay, all right, okay, doke.